Hey everyone, my name is Mark. I hope you had fun with today's Advent of Code. I just want to give you a quick walkthrough of my solution and mostly focus on what I think for the way I solved this particular problem, the required Python knowledge that sits in the background of this. 'Cause it's always interesting and fun, I find, to unpack what techniques you've actually used when solving a particular problem. So I'm not actually going to talk through the problem in much detail. Hopefully if you've solved it, you're pretty familiar with it. The solution is to verify does give the correct answers. I'm going to talk a little bit about the input data. So obviously we've got some data here, which I tend to dump into an input.txt file and then process line by line if required. So we've got two integers sat on each line, and what we're going to want to do is get at least in Python, the way I solved it, we're going to want to get two lists. List 1 holds the column on the left here, and list 2 holds the column on the right. So we're going to break this into 4 parts. We're going to look at loading the data, we're going to look at processing the data, we're going to look at solving part 1 and part 2. So it probably took me around 10 to 15 minutes to solve the problem. So obviously this can be probably done in much better ways. I'm just going to talk through how I solved it. So the lens through which we're going to do that is so-called dependency or prerequisite graphs. So what I'm going to do is look at a graph representation of what you would require as knowledge to solve this problem. So the nodes represent particular topics or facts and procedures that you would need to know how to apply, and the edges represent dependencies between them. So something's a prerequisite for something else if it's lower in the graph and connected via an edge. So obviously these graphs have to be DAGs, directed acyclic graphs, so we can't have any cycles. So you'll see if I drag something, it performs a check just to verify that. Quick other note is, it's absolutely my opinion. These graphs were drawn in around 15 to 30 minutes. They will absolutely be wrong. They're also not the way to do it if you actually want to teach things. If you want to teach things, you're going to have to break things up far more finely grained and introduce things much more carefully. Here I've taken a very streamlined view of what I think the required knowledge and the order for solving this particular problem. So let's dive in. So in green, we've got nodes which represent just loading the data from disk. Now obviously on the left, we can see that's essentially just 2 lines in Python, right? We can just lean on some pretty convenient functions that we have in Python and methods and just get that. But we're interested here in being able to understand this to be able to apply the knowledge elsewhere. So actually to do that, we obviously need to know how to work with files on disk. We need to know how to use the open function. Really though, we need to know what this with statement is all about, and that actually requires knowledge of context managers. We obviously then need to know how to read lines from the file, and that gives us back this loaded data. So you can see it's like 2 innocuous looking lines here in Python. You could just choose to copy them from AI or whatever, but we're interested in understanding. That understanding actually brings with it some pretty heavyweight requirements in terms of domain specific knowledge for Python. So we have to know basically like about context managers, which is at least an intermediate topic in Python. Okay, great. We've now loaded the data. Let's move over to processing the data. So again, the processing data that I wrote is 3 lines, but again, it brings with it quite a bit of domain knowledge if you want to understand these things well. So let's just talk through the solution that I took. First of all, so we want to iterate over the data, and for each line in the data, split it. That gives us back a list. So this data here will now become a list. The first item will be this integer, second item will be this integer, and we do that using a so-called generator expression. That's what these round braces or brackets do here. And then we want to essentially combine this into 2 columns of data then. So we want to take not these as pairs, we want to get everything in the first column, everything in the second column. So we essentially use this star, this so-called unpacking operator, to impact the generator into individual lists, and then we zip them, which groups the elements at the same index from each of the lists. The upshot of that back is we get list 1. I think it's actually tuples that we get back. I've called it list 1, but it's actually tuple 1 and list 2. It doesn't matter. And then we're essentially going to iterate again using this time a list comprehension. And inside this comprehension, we'll convert the string to an integer type. So looking at the graph for that, if we were to, let's just drag this over here a second. So we need to know that our data is represented as strings. We're obviously going to know what lists are. We're going to need that we need to split those strings. That's this line.split over here. We obviously have used the generator expression here, but really we probably introduced list comprehensions before this, so we're going to need to know ideally what a list comprehension is. We need to know that when we split these lists from strings, we get back a list. So list itself is a prerequisite over here. And then moving up, we need to know around like what the zip function is, that we're unpacking the generator expressions and creating iterative tuples, even though I called them list. And then finally, we use this like type conversion basics knowledge using the int function to get back our processed data. Nice. So that gives us the processed data. Let's look at the star1 solution knowledge now. That's in yellow. So let me just drag that over here a second. So again, we're going to need to know something around like absolute values and how to combine numerical expressions using built-in functions in Python. We obviously need to know that we, for this solution path at least, I chose to sort the data using the sorted function. We're going to need to know sorting basics, and then if I click on a node, it zoomed us out, that we need to apply sorted how to apply sorted to numerical lists. Let's reset the view, never mind. Then once we've iterated over this, in this expression here, we obviously needed to know list comprehensions using zip, how we were applying these numerical expressions using the built-in functions. That's the absolute value function there. And then at the end, we summed everything to get the final answer. So that gets us back the star1 solution. Okay, quickly, the knowledge for 2. So I should just say as well, I'm focusing on the Python knowledge here. You'd obviously have to realize that you needed to perform some count procedure on the elements in list 2. So for that, we use the so-called counter class. Oh, sorry, that sometimes happens. The counter class in Python from the collections library. So doing this, we can just pass a list and we get back a dictionary-like object where the keys are the items or the elements in the list, so the integers, and then the values are the counts. Now, crucially, for this solution path I took, we need to know that when you access the elements in a counter object, if it's not present, you don't actually get back a key error, you just get back the value 0, which is very convenient for this case. So here we can essentially combine a list comprehension where we use element n iterating over the elements in list 1 and multiply that by the counts of list 2. If it's not present, we'll get back 0, which won't apply a similarity score. And at the end, we sum that back, which uses the same prerequisite from star solution 1 of summing list elements using numerical expressions, because we've got a star operator here to perform the multiplication. We obviously had list comprehension basics as a prerequisite as well. And then we return the value. Now, obviously, there's a lot of things I've left out here. It's just my opinion. We haven't talked about, say, user-defined functions and everything else that you need to know that we've written here. But yeah, I hope you find this useful. You got any comments or questions, feel free to drop them below. And if you're interested in this pedagogical approach to acquiring Python knowledge or any other technical knowledge, you can check out the link in the comments below. Thanks, bye.